Good morning, everyone. I, Jalpa Kantaria, working as an assistant professor in IT department of Sardar Patel College of Engineering, warmly welcomes you all in today's webinar. As we know, today is 5th September. We celebrate this day as a Teacher's Day. Let me tell you one line for all teachers that teaching is a profession that teaches all other professions. Here, I would like to introduce our today's expert, Dr. Paresh Virparia sir, who is professor in Computer Science Department of Sardar Patel University, Vallabh Vidyanagar. Sir has completed his BSc in Mathematics and MCA from Sardar Patel University. Sir has more than 30 years of experience in academics. His research interests include the areas of computer simulation and modeling, networking, and IT-enabled services. Sir has published more than 121 research publications, including 74 international and national journal papers, one book, and 6 book chapters. He served as an expert member of NAC and NBA accreditation. He is working as a resource person for UGC NET examination since last year. He received 2 times the Hari Om Ashram Prize for Best Research Paper in Computer Science and Computer Engineering. He is member in editorial board committee in many international and national journals and served as a organizing committee member for organizing several conferences. Now, don't taking much time, I invite Dr. Paresh Virparia sir to take arc of this webinar. Now, it's over to you, sir. Please.
Thank you. Good morning, everybody. Today, on this occasion, that is on Teachers' Day, it is my pleasure to be with you. Today, we are going to discuss about this very hot topic nowadays, that is the Internet of Things. You might have come across this particular, you can say, technologies in your daily lives also. A very simple example I can give is when we are having you can say a car, and when we open that car with our remote key, then it is a very simple example of that particular Internet of thing. Another, in most of the cities nowadays, these CCTV cameras are installed. Okay, so what they are doing, they are capturing the you can say the vehicle number plate of the vehicle. Those who are you can say crossing the zebra crossing, or you can say violating the rules of traffic, whatever it is. After capturing the you can say image of that number plate, what they are doing, they are sending it to the you can say data center, from where they are fetching the name of the owner, address of the owner of that vehicle, and then they are sending the chit, or you can say a memo to the owner of that particular vehicle. So that is also an example of this Internet of Things. So this is a very you can say hot topic nowadays. If you are the reader of Gujarat Samachar, then before you can say a couple of months, there was an article in the Gujarat Samachar. It is Internet of Things, Internet સાથે connection lifestyle na 20 વર્ષ. A basic fundamentals about the Internet of Things is described in that one. In that case, I will quote some of the paragraphs. One of the things that is written is Internet of Things સૂત્રનું સર્જન 1999 માં થયું હતું. કેવિન એસ્ટોન નામના બ્રિટિશ સંશોધકે એ વાક્ય પ્રચલિત કરીને દુનિયા બદલી નાખી છે. So this Internet of Things has changed the everything nowadays. Another thing is Internet of Things. Hackersની પહેલી પસંદ. That means when we are connecting number of things over the internet, okay, obviously there is a loopholes or there is some backdoors through which intruder can say get or steal the information, or you can say the data from that one. Some of the examples that are quoted in that articles are like ઇન્ટરનેટની કનેક્ટિવિટીથી જેટલી બાબતોને જોડી શકાય છે એ તમામ ઇન્ટરનેટ ઓફ થિંગ્સ કહેવાય. ધારો કે ફ્રીજમાં ફળ શાકભાજીનો નિયમિત જથ્થો રાખ્યો છે. સેટિંગમાં એવું કર્યું છે કે એટલો જથ્થો ઓછામાં ઓછો મેન્ટેન થાય, જેથી જેવો નિયમિત જથ્થો ઓછો થાય કે તરત જ ફ્રીજ જાતે જ ફળો શાકભાજીનો ઓર્ડર કરી નાખે તો એ ઇન્ટરનેટ ઓફ થિંગ એક્ટ થઈ શકે. That means whenever we are keeping things means fruit and vegetables in the freeze, okay, and we are setting the lower limit of that one. Now as soon as the quantity of that fruit and vegetables is go beyond that particular you can say limit, then your freeze is so much intelligent that it will automatically ordered to the supplier of that one, and they will directly dispatch the items to your house. Okay? So it is an example of the you can say Internet of Things. And so many other examples are given in this particular articles. Okay, you can go through that one. Okay, now here let us start with this one. I am sharing the screen. Is it visible to everybody? Can anybody respond to that one? Whether my
Yes,
PPT is visible?
Yes, sir, visible.
Okay, okay, okay. Let's go on. So before going to the definition of the Internet of Things, you are aware about the computer network. What is it? So basically this computer network is nothing but the network of computer related infrastructure. It may consist of, you can say, computers, laptops, printers, scanners, as all that things, right? So a computer network is a digital communications network which allows nodes to share the resources. So basically this computer network is you can say established to share the resources. In computer network, computing devices exchange the data with each other using the connections between the nodes. So in that case, all the computer devices can exchange their data. Then come to the internet. You are also aware about this word internet. What is it? Basically, it is the network of networks. Okay. So the word network, internet basically means a global network or an internetwork of the different computers and computing devices. That means it is just the collection of networks. You can have one network at your institute, another network at say Sardar Patel University, another network is at GTU. Okay, when we are connecting all these networks, then it becomes the internet. And the third next is the Internet of Things, shortly known as IoT. So it is nothing but a system of interrelated computing devices, mechanical and also digital machines, objects, animals, people, everything. Okay, things means anything which are having some unique identifiers, because you require to uniquely identify all these entities. Okay, and they are having, or they must have the ability to transfer the data from a network without requiring human to human or human to computer interaction. Now when we say animal, how animal can send the data? So by having the sensors install in that animals, or you can have a camera in that particular animals. Okay, say for example, when you talk about people, then people may have also different kinds of you can say devices, like we can have smart watch, we can have a goggles, we can have a helmet, in which we have different sensors installed in that one, and they are able to send or transfer the data over the network, right? So anything where you can say having the unique identifier, and they are having the ability to transfer the data on the network or to the appropriate device, then that particular you can say things can be considered as a part of internet of things. So when we connect all the device all these things, it may be computing devices, it may be any mechanical device or digital device, it may be any object, it may be any animals or people, all together, okay, are form the internet of things, IoT. In internet of things, the scope of this internet is going to be expanded. Okay, so the scope of the internet is just limited to the computer and related peripherals, but now in this internet of things, the scope is you can say expanded. So it is going to be expanded beyond computing and computer devices being connected. It is going to interconnect different things, that physical objects that we see around us, the different objects like a lightning system in the room, fans, air conditioners, and anything and everything, including the things such as microwave ovens, refrigerators, televisions. So that are the household devices, right? Not only household devices, but in our business we have different kind of machines, okay, then different kinds of equipments that can also be you can say included or connected to this internet of things. So each and everything that we see around us, that we use at our home or in business or at our workplace, everything being interconnected. So this is the whole vision of the internet work of things, and that is nothing but the internet of things. So in general, we can say that the Internet of Things is the network of physical objects or things embedded with electronics, software, sensors, and network connectivity, which enables these objects to collect and exchange the data. That means here, through this particular Internet of Things, we can connect different types of objects, but those objects which are having the capacity or which are having the capability to exchange the information. Now, to exchange the information, they require some sort of you can say hardwares, or you can say software, or sensors, or some sort of network connectivity also. It may be wired, it may be Wi-Fi, it may be via Bluetooth. Any kind of you can say connectivity can be used in that Internet of Things. So IoT allows object to be sensed and controlled remotely across existing network infrastructure, and to create and creating the opportunity for more direct integration between the physical world and the computer based system, and resulting in improved efficiency accuracy, and economic benefit. So, as I have mentioned that the things in the world internet of things, the things can be anything. Okay, so things in the IoT sense can refer to a wide variety of devices like heart monitoring implants also. Okay, there is a device uh, uh, which is you can say implemented in the heart, that just to monitor the heart. Then biochip transponders on the farm animals, as I have mentioned. Okay, you can have a chip on the animals, and they can send the you can say data to the server also. In the automobiles also, we are having different kinds of sensors. So DNA analysis devices for environmental or food monitoring, or field operation devices that assist firefighters in search and rescue operations. Right. These devices collect the useful data with the help of various existing technologies, and then automatically flow the data between other devices. That means they will collect the data using their own, you can say, sources, or you can say technologies. Like, say, for example, as far as the farm animals is concerned, they are having a biochip. So biochip will collect the data, and they will send, or they will you can say broadcast that data to the other device. So here the Kevin Aston, that's a co-founder of the Auto ID Center at MIT, first mentioned the Internet of Things in his presentation that he had made to the Procter and Gamble in 1999. So as I have mentioned in earlier, okay, it is 20 years old. The concept of this Internet of Things is totally 20 years old. In the countries like India, okay, we have not that much awareness about this one, but in developed countries like UK, USA, Japan, they are using this Internet of Things since long back. As far as statistics is concerned, in 2017, there were around 8.4 billion connected things in use worldwide, according to the Gartner, one of the research group. Okay, they have, you can say, published that in 2017 there were around 8.4 billion connected things to this Internet of Things, up to 31% from the last year, that is from the 2016, and that figure is expected to zoom to above 50 billion by the end of this 2020. So that they have forecasted, okay, that by this end of this 2020, it will reach to the 50 billion devices, or you can say 50 billion things connected to this one. The global market value of this IoT is projected to reach around 7.1 trillion dollar by the end of 2020. So there is a huge scope in this particular field, that is in Internet of Things. The networking firm also noted that about 100 things currently connected to the internet every second worldwide. Okay, in a 1 second, approximately 100 things are connected to the internet, and they are forecasting that it will reach to 250 per second by the end of this 2020. Okay, so every second around 250 things are connected to this internet, or Internet of Things, uh, every second or per second. This particular figure shows the current status and the future prospect of the IoT. Here in the 2003, it is showing that the connected devices per person is 0.0, This is in terms of uh, connected devices per person ratio. Okay, that is 0.08. And number of connected devices in general is 500 million in total. And the world population at that time was 6.3 billion. That reaches to, you can say, 6.8 billion in 2010. And in 2010, the ratio of the connected devices to person is 1.84. That means per person, there is a 1.84 devices connected to the internet. And in 2015, the ratio is jumped to 3.47. And at that time, the number of connected devices is around 25 billion, and the population is 7.2 billion. And it is expected that at the end of this year, that is 2020, the ratio reaches to 6.558. That means per person, 6.58 devices are connected to internet. Okay, you can see that figure in world population and connected devices. World population is approximately 7.6 billion, but the total number of devices that are connected to this one is around 50 billion. Okay, that's the ratio is about 6.58. So if you look at the increase in the world population, it is 6.3 to 6.8 to 7.2 to 7.6. It is not that much. But if you look at the number of devices connected to this IoT, it is tremendously very high. Okay, so there is a very good opportunity in the field of Internet of Things field. This also shows the growth of these PCs, smartphones, tablets, and IoT year-wise. So this uppermost, that is the brown color shade, is for IoT, and that is increasingly very high. Yeah, if we look at the evaluation of this Internet of Things, then in the early days, before this internet came into picture, that means a pre-internet time, there is a human to human interaction. Okay, so via a phone, landline phone, okay, one can do the you can say uh, communication. Then with these smart networks, there is an era of internet. Okay, so www came into picture. It is around 1991. So through that, we can send the information through email. We can have some entertainment on this internet. Okay, then there is a era of internet of services. By adding some IT platforms and services, we can have the internet of services. So in that case, we have a e-commerce, e-productivity, means people can buy, purchase, or you can say sell the items. Okay, they can have the auctions. Everything came into that particular era. And then there is a era of internet of people, by including the social media like Facebook, YouTube, Skype. So people can talk to each other using this type of, you can say, facilities. And then after, there is a era of Internet of Things, in which it is possible to have the communication between machine to human, human to machine, like that. Okay, so by adding the different technologies, uh, we can have now this Internet of Things. This is almost the similar kind of slides. Basically, this Internet of Things is not the result of a single novel technology. It is not just a single new technology. Instead of that, Several complementary technical developments provide the capabilities that taken together help to bridge the gap between the virtual and the physical world. That means there are a number of you can say technical developments involved in this internet of things. It's not only a single technology, like the capabilities includes the communication and cooperation, addressability, identification, sensing, acquisition, then embedded information processing, localization, user interfaces. So the development in all these areas are the part of this internet of things. Now, the Internet of Things hardware, that means how the hardware or which kind of hardwares are basically used to establish this Internet of Things. So, the hardware of the IoT mainly includes the IoT sensors. Okay, it is most widely used, you can say, components to establish this IoT. Then IoT wearable electronics, RFID is also one of these. Then standard devices are also, you can say, used to establish this IoT. As far as these IoT sensors are concerned, various kinds of sensors are available. The purpose of these sensors, or the basic function of the sensor, is to collect the data and then broadcast, or you can say send it to the appropriate place. Okay. I'll show you the different kinds of sensors in a one slide afterward. But the most significant part in Internet of Things might be sensors. This device is comprised of RF modules, energy modules, power management modules, and sensing modules, which are used to accomplish the communication through their signal processing, Zigbee, radio transceiver, Wi-Fi, Bluetooth. Okay, that means whatever the information that they are collecting, that they are communicating to the other you can say device via any kind of technologies. It may be you can say Zigbee or radio transceiver or Wi-Fi or using Bluetooth. They are sending that information to the other device, or you can say a server, whatever it is. Some of the measurement devices used in IoT are accelerometer, temperature sensors, gyroscope image sensors, light sensor, pressure sensors, proximity sensors, humidity sensors. Okay, number of types of sensors are available using which we can collect the information, and then that information is then broadcasted to the appropriate device. Then another is RFID. So RFID technology being used, this RFID tags, RFID readers. Okay. So RFID based devices are required for building the Internet of Things. So you might have heard about this use of RFID. Okay, at the you can say toll plaza. Nowadays, this RFID is very much you can say useful. And standard devices of IoT, like cell phones, desktop, tablets, remains essential part of the Internet of Things as the command center, or you can say remote. The cell phones permit some important settings, alteration, and also gives remote functionality. Other key linked devices comprise standard network devices like switches, routers. Okay. And the another you can say the device that is used to form the IoT is wearable devices. Okay, the wearable devices means the human being are wearing the devices, can also use to collect the information and send it to the appropriate device, or you can say center. So wearable electronic devices are nothing but small devices worn on the neck, head, arms, or on the feet. Some of the examples are mentioned over here, like on head, we have helmets, glasses, in which we can have some sensors or some sort of technologies through which we can collect the information and then broadcast it. In a neck, we can have jewelry, collars, in which we can install some cameras, or you can say some sensors that will capture the information and send. On arms, we have a smart watches, wristbands, rings. Okay. In a feet, we can have socks, shoes, in which we can have this type of you can say uh, technologies installed in that one, which are used to collect the information and broadcast it. So these are the some of the hardwares that are basically used to create the Internet of Things. This is just a roadmap. Uh, in earlier stage, we have just the communication between host. So that is, we can say, a network. Then communication between host and a web. We can have internet. Then communication between host, mobile, and web. It is a mobile internet network. Then we have a communication between host, people, mobile, and web. So, and lastly, we have a communication between every objects. Objects may be any kind of objects which is capable enough to get the data and you can say send the data. If you look at the features of the Internet of Things, then the important features of the Internet of Things involve the connectivity. Different kinds of connectivities are required to be involved in this Internet of Things. Then artificial intelligence, AI, is also very useful, you can say, features. Active engagement, sensors, and the use of these small devices, as we have seen earlier, are basically used in the Internet of Things. This is just a basic architecture of this IoT. At the bottom level, we have a sensing and identification devices, as we have discussed okay earlier, that the sensors, RFID, smart devices, GPS, all they are collecting the information through that particular, you can say, device. Then it is forwarded to the appropriate network. So we have a network of this devices, or these devices are connected to a particular network. Then that is sent to the center where the informations are processed by using different technologies, maybe say data mining, or these smart decisions are taken using artificial intelligence, and so on. And then this information that is processed over here is integrated to the applications. Okay, so that it may be applied to the green building, or smart cities, or smart transports, or in the you can say medical, or you can say hospital management, something like that. So if you look at the advantages of this Internet of Things, here I have just listed out some of these, but we have lots of advantages. IoT network benefits not one but all in the sense individuals, society, stakeholders of the business, etc. Due to the fact that IoT network saves the time and money also. IoT systems delivered fast and accurately, with minimum utilization of energy, so it improves the quality of life. So one of the biggest advantage of this Internet of Thing is to improve the quality of life. This IoT is used for patient monitoring also. For example, various types of wireless sensors are installed on the patient body, which communicate with the IoT network and provides all the required information of the patient under treatment. So no need to, you can say, monitor the patient physically in the hospital. Okay, if appropriate type of sensors or appropriate type of implants are implemented in the human body, then doctor can monitor that patient remotely from anywhere, because that sensors, that devices will capture the, you can say, patient information and broadcast it to the center, and the doctor will fetch the information from the center. Another advantage we can say is IoT concept is used in home security devices also, which are monitored and controlled either locally or remotely using easy to use applications available on mobile phones or smartphones. So this concept is also, you can say, used nowadays also, that you can install the security system at your home, and you can assign some mobile phone to that particular system. So whenever any threat occurs, then immediately it will alert on your mobile phones. Okay. So the typical IoT devices are security alarms, cameras, sensors, door locks, etc. IoT is used in asset and individual tracking, inventory control, energy conservation, shipping, etc. It is similar to machine, but it has application beyond some machine to machine interaction also. Because in a machine to M, machine to machine, there is a communication between machine to machine only. Whereas in IoT, things communicate themselves to its owner, indicating its location and condition. Means here it is not required to have the communication between machine to machine, but anything to anything. Okay, anything to anything. It is just beyond this M to M concept. Yeah, this is just the difference between that M to M, machine to machine, and IoT. Because here on this IoT, we have some more, you can say, advanced concept. But in that case, it is required to have the internet connection. Okay, or not internet, but you should have some sort of, you can say, technology through which it can send and receive the data. Yeah, as far as opportunity for the IT people is concerned, okay, then uh, we have at the consumer side, we can have a smart home control. Means we can have lighting system, security system, comfortable items also, optimized energy use also, maintenance. Okay, for all that things we can use this IoT. Then in retail, product tracking, inventory control, focused marketing. Okay, we can use this IoT in a medical field. This using this wearable devices, implanted devices, telehealth services. This IoT can be helpful. As far as military is concerned, for resource allocation, threat analysis, troop monitoring, we can use this uh, Internet of Things. As far as industry is concerned, okay, we can have a smart meters, wear out sensing, manufacturing control, climate controls. Okay, for that this IoT can be used. Then in this automotive field, we can use this IoT for parking, for traffic flow, anti-theft location also we can use. And in this agriculture, this can be used for the crop management, soil analysis. So as far as soil analysis is concerned, we can say there are some different kinds of soil sensors are available, using which we can collect the data and we can analyze the soil. What is the type of the soil, which kind of crop can be grown in that particular soil, when it is required to irrigate the soil. So that type of you can say questions can be very easily answered if we are having this particular you can say IoT for soil analysis. So there is a lot of opportunities of this IoT in various kinds of you can say applications. So here are the slides that described the you can say the earlier figure in detail. As far as building and home automation is concerned, for improving the security to decreasing energy and maintenance cost, there are mainly companies offer a wide range of advanced IoT technologies for controlling and monitoring the smartphones and intelligent buildings. Can have access controls, light and temperature controls, energy optimization. Light and temperature control means through your mobile phones, you can very easily control the lights. You can very easily control the temperature also. Okay. Yeah, this figure shows the sort of you can say home optimization, automation. Sorry. uh, we can have different components in our light in our home, like lights, speakers, window sets, laptop, TV, tablets, freeze, garage door. So everything we can control through our mobile phone, or you can say with a remote. Okay. Only thing, all these devices must be having some technology through which they can broadcast or they can send the data or they can receive the command. You can have a smart cities, wearables as we have seen earlier. Okay. Yeah, in the case of a healthcare, this is also very much useful. Smart manufacturing, that means in the industries, it is also very much helpful in automotive. This is one of the example. This is a one smart egg tray. So this egg minder synchronize with your smartphone to tell you how many eggs you have got at time and when they are going to bed. Okay, when they are expired. Okay, so they can see the quality of that one, and also the purchase date and all that things are kept in this particular smart egg tray, and which will communicate to you about the you can say eggs. Then you can have a smart washing machines, smart lightings. Through that particular you can say device, you can control the lights within your bedrooms. Smart sleep systems, smart weather stations, smart slow cookers, smart garbage cans. So in developing countries, this type of things are already there. Means this big belly alerts when it needs to be empty. So whenever these garbage cans are full, okay, then it will send a message to the center, and the center will send the vehicles to clear this particular garbage cans. So this type of technologies are already there in the developed countries. Smart gardenings also, when to irrigate, when to do some harvesting in that one. So everything can be you can say controlled. So as far as the IT students is concerned or the computer science student is concerned, what are the challenges? So some of the challenges for the you can say IT peoples are like this one. As I have mentioned, security. As we know that in this IoT, different kinds of devices are put together, right? So when they are put together, definitely there should be appropriate security system. Otherwise, any intruder can hack the information and they can steal the you can say important information from your network. So security, privacy, scalability, technical standardization, interoperability, software complexity, data volumes and interpretation, power supply, interaction and short range communication, wireless communication, fault tolerance. So these are the some of the challenges that the IT people have to face, or they have a opportunity to work in this type of areas in the field of IoT. Okay. If you look at the technological development of this IoT, then cloud backends are crucial for IoT deployment. That is why both the Amazon and Microsoft added a number of new features to their IoT cloud offering in 2017. Microsoft, for example, launches Microsoft Azure IoT Edge. They are providing this facility in their cloud iOS, Microsoft Azure, that allows for small devices to run cloud services even when not connected to the cloud. Even in a similar move, Amazon announced further device management and device security features in the November 2017. Google launched its Cloud IoT Core service in May 2017, allowing for easier registrations of IoT devices to the cloud as well as a protocol bridge that natively supports typical IoT protocol. So this Google, Amazon, Microsoft, which are the you can say main business people in the form of cloud, are also providing some sort of you can say features related to this IoT. This is almost similar to the earlier slide, which shows the opportunities in different fields. Okay, now as far as the student is concerned, suppose you are the students of engineering, okay, and you require to perform some sort of experiment in your laboratories or at your home or at your workplace, okay, then there are number of you can say hardwares which are available using which you can perform some sort of you can say experiment related to this IoT. So you might have heard about Raspberry Pi, Arduino, YPay, Intel Edition. Okay, so all these are the you can say the boards which are available through which you can do some sort of you can say experiment in the field of IoT. So this Raspberry Pi is the name of the series of single board computers made by the Raspberry Pi Foundation UK. The Raspberry Pi launched in 2012, and there have been several iterations and variations released since then. Means number of new versions were introduced in this one. All over the world, people use these Raspberry Pis to learn programming skill, build hardware projects, do home automation, and even use them in industrial application. So through this particular Raspberry Pi, one can do this type of things. Raspberry Pi is a very cheap computer that runs Linux, but it also provides a set of general purpose input output pins that allows you to control the electronic components for physical computing and explore the internet of things. That means they are providing different pins through which you can connect your electronic gadgets or electronics, you can say machines or whatever it is, and you can control them, okay, and you can explore the internet of things. Another very popular is Arduino. Arduino is also an open source electronic platform based on easy to use hardware and software. Arduino boards are able to read inputs, that is a light on a sensor, finger on the button, or a Twitter message, and turn it into an output like activating the motor, turning on or off the LEDs, publishing something online. Okay, so it will receive the inputs and appropriate output will be, you can say, given to the appropriate device. The software used for Arduino device is called IDE, Integrated Development Environment, which is free to use and required some basic skills to learn it. It can be programmed using C or C++ language. So these are the two basic, you can say, boards available through which you can do some experiment at small levels, means in your lab or at your home. These are the different sensors, as I was mentioned, okay, earlier, that different kinds of sensors are available, and you can use these sensors to collect the information and then send it to the appropriate machines. This is just a cartoon. Okay, so whenever you are taking some items from the fridge, then based on the calories of the, you can say, items that you have collected from the fridge, it will show you, okay, oh, warning, you have collected the items having more than 1,000 calories. And the second one is, it shows here, internet of things, that I told you to pick up the milk on the way home. That means this smart fridge have already sent a message to this person on his mobile phone, okay, that while coming to the home to collect the milks, okay, but you forgot about that one. Okay, I have some video. Let I show you one or two. So this is all about the basics of Internet of Things and the opportunity in the field of IoT. Right? You can see so many videos and so many tutorials on the uh, YouTube. Okay, to make this particular concept very clear. Okay, now I have completed my presentation. If anybody is having any questions. What are the most used sensors in IoT? So there are so many, depending upon the you can say the type of the work that you are doing. For example, if you are analyzing the soil data, then obviously the soil sensors are required. If you are monitoring the patient information, okay, then obviously you require the sensors which can be implanted in the human body. If you are monitoring the you can say climate data, obviously that type of sensor. So depending upon the requirement, different kinds of sensors are basically used in IoT. Difference. So both are you can say work for different kinds of operations. Depending upon the availability you can use, and also depending upon the work that you want to carry out, you can use any one of these. Both are used to establish the IoT at the you can say laboratory level.
Okay, sir. There is no further question from today's right?
Okay, okay, ma'am.
Okay.
Thank you very much.
Thank you, sir, for giving us in depth and basic knowledge about IoT and what is current status and future perspective of IoT and what are the hardware devices used in development for IoT. So before signing off this webinar, I am much obliged to our all dear participants for sharing your presence today. I would like to thank my gratitude to our campus chairman Sri Girish Patel sir, secretary Sri Sheetal Patel sir, and campus development officer Dr. Swapnil Patel sir for blessing us for this webinar. Thank you, sir, once again. Thank you.
Thank you very much.